Hi, I'm Lalit, and I'll be discussing the week 0 assignment for computer vision course offered through NPTEL. So we first look at the question 1. We are given a set of uh, linear system of equations. We are given three equations, and we need to check the number of free variables provided in these equations. So first we create a augmented matrix like this, where we see that the coefficients are given there, and then the right hand side is also given in the last column. With this, we first try to find the row echelon form, for which we do some row operations. So we first update the second row by subtracting it from first row, which gives us something like this. Next, from this, we would like to swap the first row to that of second to bring 1 onto the column on the first row as the pivot element. That means it will just be like this. And from this, we would now make the pivot of the second element, second row, given with the following operations. We take the second row and subtract the second row with 2 times of the first row. So this gives us the first row is same, the second row we are subtracting it with the 2 times of the first row, and again for the third row we try to make the first element 0, which means we are subtracting the third row with that of 9 times of the first row, and it gives 0, 22, 10 minus 2, and the last one is 20. Okay, and then further we now do we remove the third we reduce the third row like this. Take the third row and then subtract it with 2 times of the second row, which gives us so the first and second row is same, and we see that there are all zeros in the third row. And just to make it row echelon form, we divide second row with that of the pivot element value, which gives us 1 minus 2 minus 1 minus 2 0 1 5 by 11 minus 1 by 11 10 by 11, and there are all zeros at the last. So as we can see that we have two non-zero rows. So it means that we have two free variables. So we can only determine two variables, and the total number of variables is 4. And there are two non-zero rows. So this ultimately gives us there are two free variables. Okay, so we move on to the next question. So our next question is find out the eigenvalues of matrix A and the corresponding eigenvectors. So for finding out the eigenvalues, we need to find the characteristic polynomial, which is given by, just change the pen back to the original color. A minus lambda I, determinant of it is 0, which if we take this specific matrix, we first try to write A minus lambda I determinant, which is minus 2 minus lambda minus 1 minus 3 minus lambda. So if we try to open up this determinant, it will be like this.
Plus 12.
Plus 12i. Okay, I made a mistake here.
You don't talk?
This is fine, right?
Okay. I can comment, right? That's fine.
Yes. So this leads us to lambda square plus 5 lambda minus 6. And if we equate this equation to 0,
Plus 6.
it will be minus
Okay,
6.
correct.
It will be minus
Okay.
So
Yeah,
this
the
will
minus
turn
12.
out to be lambda plus 6 and lambda minus 1. So which gives us lambda is minus 6 and 1. So we got the two eigenvalues for the given matrix. Lambdas are fine. Now we want to find the eigenvectors. So we first look at lambda equals 1. So for lambda equals 1, if we write the same equation, Ex equals to lambda x, or maybe we can just write it as A into v1 is equal to lambda 1 v1, where lambda 1 equals 1. If we rewrite the whole matrix, then v1 will be containing x1 and x2. Lambda 1 is 1, and so we have again here 1 times x1 into x2. So if we solve this, we get x1 by x3, sorry, x1 by x2 equals 1 by 3. So our v1 will be some constant times 1 by 3 comma 1, where this constant k1 belongs to any real number, and k1 is not equals to 0. So with this we get our first eigenvector, and then we look at the second eigenvector, which is for lambda equals minus 6. For this we again rewrite the matrix. But here it will be like this: minus 6 times x1 minus 6 times x2. So this is again coming from ax equals to lambda x equation. From here you get something like this: x1 by x2 equals minus 1 by 4. So this leads us to the other eigenvector as k2 times minus 1 by 4. Sorry, minus 1 by 4, here again k2 is a real number and it is not equal to 0. So given this, our correct option will be B. So the answer will be option B. Okay, now we can move on to the next question. So we are given three vectors v1, v2, v3 and a vector y. So I need to copy this part as well. So our question is, what can be the value of h so that y lies in the span of the three vectors v1, v2 and v3. So if we want y to lie to be a span to span these three vectors, so it should be a combination of y should be a combination of all these three vectors: a v1 plus b v2 plus c v3, which yeah, okay, which means that we can do it another way as well. We'll again construct a matrix like we constructed earlier. And we try to find the row echelon form of this matrix, which can be done by R1 is we'll modify the second row first by adding second row to the first row, and also we'll modify the third row by adding third row to that of two times of the first row, which gives us something like this. And now we'll try to remove the last row as well by using the second row, which gives us something like this. The first row remains the same, second row also remains the same, and the third row becomes all zeros, but the last element becomes h minus 5. So if So since we see here that there are all three zeros which is spanned by the three which corresponds to the three vectors v1, v2 and v3. To keep the vector y in the span of three vectors v1, v2 and v3, we have to make this h minus 5 0, which leads us to the answer h equals 5, which is answer is option A. Okay, then we move on to a different set of question. We'll move to question 6. So we are given vector y and vector u, and we need to compute the orthogonal projection of y onto u. So you can think of it like this. So you have a vector y and a vector u. This is vector u, and you want to get the orthogonal projection of y onto u. That means this is 90 degree and this is y at this vector which I am showing now in green is y hat. Okay, so with this so how can you get the projection? So we have the nice projection formula. Y hat is given as u transpose upon u transpose u into y. So u is the vector onto which you want to find the projection of y. So if we simplify it, it is u transpose y upon norm u whole squared into u. If we go further, u transpose y is just a dot product of these two vectors, which is element wise multiplication and then the sum of the elements, which is 7 into 4 28 plus 12 40. And norm u is just the Euclidean norm out here, which gives us 20, and we replace u with that of two vectors, two elements of the vector 4 and 2. So our final answer is 8 and 4 on this vector containing the elements 8 and 4, which is option A. And then now we move on to the next question. So a single die is rolled once. Assume that the die is fair. That means for all 6 sides of the die, we have the same probability, which is 1 by 6. That means probability of any side is 1 by 6. Find the probability that the result of a roll is a number less than 2 and even. Okay, so what is S? Let S be the sample space, which will contain all the 6 possible outcomes. It contains all given all the possible outcomes, now what is probability? Let A be the event that roll is less than 2. That means A contains just 1 in the set of all possible events. And B be the event that roll is even. That means B will contain all the elements which have even outcomes, that is 2, 4 and 6. So what we need is find the probability that the result of the roll is a number less than 2 and even. And here means we need to take our final event is A intersection B, since we are concerned with the AND part of it. So given this, we have A intersection B is empty set, or we can call it as phi. So given that A intersection B is empty, probability that A intersection B will be 0. So the answer is option C. Okay, we move on to the next question. So we have a standard normal variable z. Z is standard normal variable, which means it's Gaussian with mean 0, and variance 1. And then we have another random variable, x is sigma z plus mu. So we want to understand what distribution does x follow. Okay, so given that x equals sigma z plus mu, so with this information we can imply that expectation of z is 0, which is the mean, and expectation of z minus mean whole square, which is the variance, which is just expectation of z square in this case, is 1. Okay. So now we are given x equals to sigma z plus mu, which implies what? Doesn't. Now we want to get the mean and variance of x. So for that we take expectation of x. Expectation of x is, we'll just replace the expression out there, sigma z plus mu, which gives us sigma times expectation over z. Because z is a random variable, sigma is a constant, plus mu. Mu is also a constant, and expectation of 1 is 1. And from here we see that expectation of z is 0, which gives us expectation of x is mu. That is, the mean of the random variable x is mu. We now move on to the next thing. We want to find the variance, which is x minus mu whole square expectation. So how can we write it? Since we No, x minus mu is what? Sigma z, right? So we write expectation over sigma z whole square, which is sigma square expectation of z square, and from here we see that expectation of z square is 1, which gives us the variance of x is sigma square. So our answer is D. That means x can be written as a normal variable mu variance sigma square. Okay. We now move on to the last question. Okay. So which of the following are properties of Poisson experiment? So what does a Poisson experiment mean? It defines the number of occurrences in a certain space or time. That means for a given variable out there, which is continuous like space or time, we want to check the number of occurrences of an event, which can be classified as success or failure. Okay, the first one is directly implied by the definition of Poisson experiment, that we can consider each occurrence as success or failure. So we say that the experiment results in outcomes that can be classified as success or failure. This is correct. The probability that a success will occur is proportional to the size of the region, which is true because if the, for instance, if we are measuring the number of phone rings in a given time period, in an expected sense, for instance, if you have 5 phone rings per day, if you extend the time period for 2 days, our expectation of phone rings will increase to 10. That means the probability that success will occur is proportional to the size of the region. Okay. The next one is the probability of that a success will occur in an extremely small region is virtually zero, which is also true now. Why? Because now if I reduce the time period during which we are measuring the phone rings, that is from 1 day to 1 minute, we cannot expect 5 phone calls just in a minute. The occurrence of such phone calls will reduce drastically if we consider just 1 minute. So this is also by definition of Poisson experiment. And the average number of successes mu that occurs in a specified region is unknown. This is false. So the Poisson distribution is given as probability that a random variable x, which is what we are counting, the number of occurrences, is equals to a particular value k, is given by lambda to the power k to the power minus lambda upon k factorial. So the average number of occurrences means we have to take the expectation of this random variable x, and if we try to solve, it gives us lambda itself. That means we know that the average number of successes for a given specified region is fixed, which is given by the parameter lambda for the Poisson distribution. Okay, so we'll end the session now. Thank you.